welcome everybody for the Ticket 2010. There is a small confusion here. Actually, if you see the template what we have, it's showing as a SCOM, okay, here, but it's not a SCOM. That was a print mistake. So this is the Active Directory, the repeat of the Active Directory which we did in the morning. Okay, so if you have missed this session in the morning, you can just attend this. Okay, you'll gain the AD knowledge. Okay, and what we're going to discuss here is we're going to take a look at the troubleshooting part. Okay, we're going to take a look at the Active Directory. What are the problems we can see with the Active Directory? The network dependencies, diagnostic tools, file replication surveys, best practice diagnostic tools, and the DNS. All this. Okay. My name is Maha. Okay, I'm a premier field engineer. Okay, my job is to go on field, work with the customer, help the customer, educate the customer. Okay, if a customer has, I do both proactive and reactive. Okay, if a customer wants any help from us, I go and help the customer. And if a customer has a firefighting issue, okay, I go and help the customer for the Active Directory. Okay, and I work for Microsoft New Zealand Limited, and I'm based in Wellington. Okay, here is the session is designed to provide attendees with the common pain points. Okay, this is what I have seen with the different customers. With the Active Directory, they will be having small issues, some big issues, and why we get those issues. When I'm talking the issues here, if you have faced those issues in the field, you can easily recall and you can compare that with this one. Okay, it might be because of this the problem was caused. Okay. So before going further, okay, let's take a look at the replication topology here. Okay. If you see here, this is the replication topology. Just want to give a basic idea of what exactly the replication and how exactly the replication works. Okay, we create a site. This is a site A. Okay, if you see here, we have a site A, and here is the site B. Okay, and here's the site C. Okay, and these are the domain controllers. Okay, the domain controllers maintain the Active Directory. Okay, the domain controllers will have Active Directory which will maintain the domain, right? So here if you see I have 3 domain controllers in this particular site. Okay, the users who log in, they log into one of the domain controllers in this site. Okay, so what happens is, okay, I have a domain controller here, I have a domain controller here, I have it here. What happens if I bring one more domain controller here? Okay, how does these domain controllers understand that I have a new domain controller? Okay, what happens is we have a process called as KCC. KCC is a knowledge consistency checker. Okay, this process runs on every DC every 15 minutes. Okay, it runs on every DC every 15 minutes. It identifies if I have a new DC, if I have a DC which is gone. Okay, based on that, it creates a connection object. If a DC has come up, it makes sure that the connection object is created for the outbound connection. If a DC has been gone down, it makes sure that it deletes the connection object. Okay, but you need to be very careful. If you have created a manual connection object, the KCC is not going to remove that manual connection object. Okay, KCC thinks that you are managing your AD by yourself. Okay, normally we request customers to leave the KCC as it is for automatic connection generation. We do disable the KCC if you have more than 120 sites. Okay, what happens if you have more than 120 sites? The algorithm what the KCC uses to generate a connections to different domain controllers, it will not work as expected. What it does is it tries to make a mesh topology, okay, which is not good for Active Directory domain environment. Okay, so the KCC makes sure that the connection object it creates a connection object so that the replication can happen between domain controllers. Okay, and if you see here, not all the domain controllers are talking to all the domain controllers in the other site. Okay, what is happening here is, what we do is we elect one of the server as a bridgehead server in one particular site. Okay, who does that? We have a process called as ISTG, Inter-Site Topology Generator. Okay, like a KCC intersite topology generator runs on every DC every 15 minutes. Okay, if I have to give an example here, if you see here, the ISTG role is running here, but the bridgehead server is this one. Okay, ISTG role can decide whether he can become a bridgehead server or he can assign the other DC to become a bridgehead server. Okay, so here the ISTG runs after every 15 minutes. It tries to query that who has got ISTG role. Okay, if this DC is gone down, he automatically takes the ISTG role ownership. Actually, he checks with this DC. If both are down, okay, he automatically takes the ISTG role and he becomes a bridgehead server. Okay, like a bridgehead server, you can manually create a bridgehead servers. Okay, but if you have created a manual bridgehead server, the ISTG is not going to do the automatic election, all that process. Okay. So this is about the sites, okay, and here we have a site link, okay. If you see here, we have created a site link from site A to site B. Based on the site link, we create a connection object, okay, from site A to site B. Okay. So if I create a site link between the site link from here to here, the site link creation is a manual process. I create a site link, and then based on that, the KCC actually, the ISTG elects the one as a bridgehead server. From this bridgehead server to this bridgehead server, again the KCC makes a connection object. It creates a connection object. Okay. So this is just a basic, very basic theory of the Active Directory, domain controllers, and all that. Just to understand for our next components, what we are going to discuss here. What we are worrying here is, okay, the replication fails. Okay, when the replication fails, when this domain controller wants to replicate from this domain controller, the replication fails. Maybe when this domain controller wants to replicate from here to here, the replication might fail. Okay, so let's take a look at those things. Okay, why the replication gets failed. Okay. So when the replication fails, okay, how do we know that the replication is failed? Is because of the error message. Okay, so we have a few error messages which are important. Okay, the access is denied. Okay, access is denied is one of the error message we get when you want to replicate the domain controllers. How many of us have seen the access is denied? One, good. Okay. And we get one more error message is RPC server unavailable. Okay, so why do we get RPC server is unavailable? Is basically we have a communication problem. We have a network issue. Maybe the port is blocked. Okay, so that time we get a RPC server is unavailable. Okay, we have one more error message called as target principal name incorrect. Anybody have seen this error message on the domain controller or maybe on the workstation? Okay. So I'll discuss on the target principal name incorrect after discussing these three. Okay. So these are we do get some more error messages with Active Directory, but these three are the basic error messages. Okay, access is denied, RPC server unavailable, target principal name incorrect. Okay, if you don't take care of these three error messages, what happens? You will end up with an error message saying that a target domain controller is rejecting the connection. A source domain controller is rejecting the connection. There is a lingering object, so the connection has been rejected. DC got tombstoned. Okay, all those things will start if you don't take care of these three error messages. Okay, and there are some other error messages like a ATDS database got corruption and all that. Those things are not related to this one. That's again a separate issue. Okay, so let's go into the deep. Okay, why do we get access is denied? Okay, the error message is saying that access is denied. It means that the domain controller don't have access to other domain controller. Okay, so if I go here, okay, the best example what I can give you here is, I will not be able to reproduce the issues here because if I want to give access is denied the issues, if I want to show you, I'll get a blue screen definitely. Okay, so what happens here is, okay, if you see here, this is one of the domain controller and this is my second domain controller. Okay, so this domain controller has got an account called a system account. Okay, the DC I also logged in, but the DC is also has got its own account, right? So what happens is, if the time actually changes plus or minus 5 minutes, what happens? Okay, if the time changes plus or minus 5 minutes, okay, the Kerberos has got a rule saying that if there is a time drift happens plus or minus 5 minutes, then the authentication will fail. Okay, so by somehow, okay, if this DC has got pointed the time to one of the time source, different time source, if this DC has pointed to some other time source, okay, there are chances that the time drift can happen. Okay, so what happens at that time is the domain controller actually logs into itself, which is with the system account to himself, and when it logs into itself, it has got a Kerberos token. Okay, that token is an invalid token. Okay, so based on that token, this domain controller tries to replicate with this domain controller. This domain controller looks for the Kerberos token, which is invalid, so he says access is denied. Okay, this is one type of error messages what I have seen in many cases. Okay, and there are some other reasons we might get the access is denied, especially this one. If I go to the group policy, if I go to the default domain controller policy, I go to edit this default domain controller policy, Windows settings, security settings, local policies, and user rights assignments. Okay, so if I go here, you can see here I have one of the group policy called as access this computer from the network. Okay, so I have a group policy called as access this computer from the network, and if I double click on this one, you can see, okay, who and all can access this domain controller. Okay, so the administrators can access this domain controller, the authenticated users, and this is very important, enterprise domain controllers. Okay, if somehow if the enterprise domain controllers goes missing, when this DC tries to access to this DC, we get access is denied. You get everywhere, whole forest will get access is denied. Okay, and everyone also has got access to the domain controllers. Okay, pre-Windows 2000 compatible will have access to the domain controller. Okay, every user, every computer should have access to the domain controller. Okay, what happened with the? I hope everybody heard about a virus called as NIMDA virus, right? Anybody? How many of us know about that? 1, 2. Okay, so what the NIMDA virus did was, okay, it just removed all these entries from here. Okay, so we know how to bring it back, so we did not had much downtime for that. So if this one goes missing, then you will end up with a problem called as access is denied for the domain controller's replication. Okay, we also have one more important thing here is the security options. If I go to the security options in the group policy, and this is really careful. Okay, we have these group policies. Okay, so these 4 group policies are really important. Okay, what happens is when a computer to computer, okay, we want to access another computer, like a domain controller to domain controller, or a server to the client computer, what happens is first we establish RPC channel, okay, then remote procedure call gets established. On the top of the RPC, we do something called as SMB, okay, server message blocks. Okay, the server message block, what it does is it does a digital signature on the communication. It means what in a low level, what we can say is, okay, it is something like it is trying to make a secure channel between a client and a server. Okay, whatever the communication are happening between two systems should be going through the secure way. Okay, so these are the settings for that. Okay, don't ever try to change them. Okay, if you change one, if you play around with them, okay, I have seen the whole production can go down. Okay, you can see here, this is for the every system works as a server and a client, right? We have a server service, we have a client service. Okay, so it is we have information here when you are working as a client, when a domain controller is working as a client, it means that it is requesting somebody. Okay, that it means it is a client. Okay, it has to digitally sign the communications always. Okay, or it has to digitally sign this communication if a server agrees. If a server says digitally sign the communication, then only the client is going to, this DC is going to change it to a digitally signed communication. Okay, and here is a network server. When it is doing a network server service, okay, what it has to expect? It has to expect, always it has to expect the digitally signed communications, or only if the client agrees, it has to expect the digitally signed communications. Okay, you can see here, this is my default domain policy, default domain controller policy, and you can see here these two are enabled. Okay, so what's the meaning here is, if any client want to contact the domain controller always expects the secure channel, means digitally signed communication between the client and the server. Okay, so I'll get back to you. I'll get back to you on this one again. And this is the access is denied. Then it comes the RPC server is unavailable. RPC server is unavailable is mainly because of the communication. Okay, because of the network issues, because of a port might be blocked or anything. But it's just a communication problem. Maybe DNS server is not available. The DNS server does not have a valid record for the client. DNS record does not have a valid record for the domain controller. Okay, so all that if you have all the problem, then you get RPC server unavailable. Okay, we have a target principal name incorrect. What does a target principal name incorrect does is, why we get this error message is, like a user object. Okay, the user has got a user object in the Active Directory, and I have password for myself. Right, I change the password based on whatever the max password threshold has been set. So not threshold, max password age has been set. Okay, in my case, I change the password every 42 days. Okay, in the same way, my computer is also a part of Active Directory. Okay, when a computer is coming up, when it's booting up, it also contacts the Active Directory, and it also authenticates with the Active Directory. It also has got a password in the Active Directory. Okay, it also changes the password from the Active Directory. Okay, how many days? In how many days it changes the password? Every 30 days, the computer changes its password. Okay, so what happens if a computer is not available on the network on the 30th day? Okay, so on the 30th day, the Active Directory informs the client saying that you have to change your password. Okay, what the client does is, the client will not get that packet actually. Okay, so on the 31st day, when the client comes back on the network, when the client actually tries to authenticate, the client is sending a password. Okay, if you see the computer object has got for a password, it has got a previous password attribute. Okay, so when the Active Directory was sending a new password to the client, okay, what it did was it sent a new password to the client, and whatever the existing password, it moved the existing password to the previous password. Okay, now when the client is coming up on the 31st day, it sends the previous password. So the AD understands that, okay, this is a previous password. Okay, authenticate the client. Okay, and tell the client saying that this is your new password. Please change it. Okay, so this is what happens in the real scenario. But what happens if a user is not coming back to office for 60 days? Okay, the password which was sent first time and the existing password was moved to previous password, and after 30 days again the new password was moved to previous password. Now both the passwords in the Active Directory are new. Right? So when the client actually now comes after the 61st day, okay, when the client actually tries to authenticate to the domain controller, you will get a target principal name incorrect. Okay, so this even applies for the domain controllers as well. Okay, what happens in the domain controller is, the domain controller is working fine. Okay, it will not give you any error messages. You don't monitor the domain controller. You think that everything is going fine, and one sort of fine day actually it gives an error message saying that target principal name is incorrect. Okay, maybe because of one of the port was blocked. Okay, and the DC never communicated with the other DC. Okay, so how do we fix the target principal name incorrect? For the client, actually, if client, the target principal name incorrect comes on the client, we use a tool called as NL test. Okay, by using NL test, we fix the secure channel. Or the best thing is client, you disjoin the client and rejoin the client. Okay, you get a, you use the same SID, we get a new password. Okay, for our domain controllers, we cannot use the NL test. For the domain controllers, we use a tool called as NetDOM. Okay, so here is a port. Actually, what we have are ports. Network ports. DNS works on a port 53. DNS works on both UDP and TCP. Okay, but 99% of the customers don't use the UDP for DNS. Okay, everybody blocks the UDP, so the DNS will be always working on the TCP, and I'll come back to you on that in a minute. Okay, and Kerberos works on a port 88. Okay, RPC endpoint mapper works on port 135, and here's the NetBIOS port 139. LDAP is 389, and this is SMB is 445. Okay, so what happens if a 445? What is SMB? SMB is the server message blocks. Okay, when do we use a SMB? Okay, whenever you do a / computer name, okay, you are triggering an SMB protocol. Okay, what happens when you use the SMB protocol is you need to go through the port 445. If a port 445 is not available, you fall back to the port 139. Okay, which is not a secured session. Okay, so the problem here is you have a port 445, and what the system does is it falls back to 139, and it tries to contact the domain controller on port 139. But if you see here, what we have set here is when it is working as a server, okay, always use the digitally signed communications. Okay, you cannot do the digital signed communication on the NetBIOS port, which is it's not a secure port. Okay, but you can do the secure digital signed communication on the port 445. Okay, so this is what happens, okay, in a real-time scenarios. Okay, this is one of the area where we can see the error messages. And I have seen a lot of customers. Okay, this is a port LDAP. LDAP is nothing but Active Directory port. Okay, what is a LDAP? LDAP is a protocol which sits on the TCP/IP stack. Okay, to query the Active Directory. Okay. Yeah. So we query the Active Directory using LDAP protocol, and when we are querying the Active Directory, if you see here, Active Directory has got a different partitions. We call it as a naming space. Okay, domain partition, configuration partition, schema partition. Okay. So all these, when I'm querying with the port 389, it means that I'm querying all these partitions. Okay. So what happens? What Microsoft has done here is, okay, if you see, this is the domain partition, okay, and this is the configuration partition, and this is the schema partition. Okay, whatever the objects are available in the domain partitions are also available in the global catalog. Okay, whatever the objects available in the domain partition, they are available in the global catalog, but in the global catalog they might be having a partial attribute set. Okay, they may not be having a complete attributes, but it has got a partial attribute set. But you can change that. Okay, you can change that. You can, if you have any attribute and you want that attribute to be made available in the global catalog, you just have to go and set that, make a partial attribute set to true. Okay, so if you change that, you can make that particular attribute to come into the global catalog. Okay, so what I'm trying to say here is a lot of applications actually they try to query the port 389, which is really a wrong thing. Okay, especially when the application is trying to query the Active Directory on a port 389, you can see the application actually it goes on hooks, keeps on querying. Okay, it makes the Active Directory busy. Okay, so instead of querying the Active Directory, you can query the global catalog. Okay, if you see the Exchange actually looks for a global catalog. Exchange never looks for a Active Directory. Okay, and we have our dynamic RPC ports. Okay, In 2003 XP, we have dynamic ports are started from 1024 to 65,535. In Windows 2008, Vista, Windows 7, 2008 R2, we changed the dynamic port from 49,150 to 65,535. Okay, this is really important to know if you are from the networking team. Okay, and you want to migrate to the 2008 and Windows 7 systems. Okay, not everybody, not all the customers will open these ports completely. Okay, they will just limit the RPC port. What exactly is this RPC port does is, okay, if you see here, if this is my computer, okay, so if this computer wants to talk to this computer, what this computer does is it wants to talk to this computer, it puts an IP address and it puts a port 135. Okay, so it tries to contact this domain controller or maybe the computer or server or computer, anything. It tries to connect with this one, and it puts a request on the port 135. This one. Okay, now what this domain controller does is, okay, it takes the request. This is what a three-way handshake was happening. It takes the request. It tells the client saying that, okay, you can talk to me in one of the RPC dynamic port. Okay, and leave the 135. 135 again, the request will be going to the 135 from the different clients. Okay, like this actually it assigns the different ports so that it can do the multitasking and multi-communication with the different systems. Okay. Apart from that, we have one more thing called as block hole router issue. Okay, I'm not sure how many of us have seen here the issue. Anybody have seen a block hole router issue here? No. Okay. So what a block hole router does is, if this is my domain controller and this is another domain controller, okay, in between them we have a router actually. In my case, if this is a software router, normally everybody has got a hardware router. Okay. There is a TCP/IP standard. Okay, for Ethernet standard, we have a TCP/IP protocol. What the Ethernet standard IEEE has set is for a TCP Ethernet, the packet actually when the computer actually puts the packet onto the network, okay, the packet has to get some size actually, which is called as MTU. Okay, so that MTU is supposed to be a size of 1500 bytes. Okay. So what happens is we can change that value. Okay, that's one of the mistake what we do. Okay, that MTU size is set as standard on all the Microsoft operating system as 1500. Even if you take any operating system which is using Ethernet standard, the MTU is 1500. Okay, you use a Linux, you use a Unix, you use any operating system, Ethernet standard is 1500. Okay, but on the router, some of the networking people, what they do is they change that MTU size. Okay. I asked so many customers, why do you do that? The answer is for a security reason. I don't know what security they are trying to bring here, but the answer is they say that for the security reason, they change the MTU value. Okay, what they do is they reduce the MTU size. Okay, when they reduce the MTU size, okay, when this domain controller want to talk to this domain controller, it sends a packet with the 1500 bytes, but this router, okay, will not forward the packet. It just drops the packet. Okay, it keeps on trying, nothing happens. Okay, it gets a timeout, and communication fails. Okay, especially this happens if you have a client in a site where you don't have a domain controller. Okay, I have seen a lot of issues in those kind of scenarios where you don't have a domain controller, but there is one site. Okay, where the clients are getting connected through the ISP, but ISP has set the MTU value to less than 1500. Okay, so changing the MTU value, it will take a long time because the ISP also cannot shut down the router. Okay, because not only one network will be connected. Okay, there are different customers will be connected to the router. The ISP may say that it might get some time. Okay, I had one of the customer who had the hub site was connected to 120 spoke sites. Okay, the MTU size was set as 900. Okay, and all the replication was always giving a error messages. We went and we found it. This is causing the issue, and we asked the change management to give us a green signal to go and change the MTU size. Okay, and we got the response that you cannot change the MTU for next 3 years. Okay, so they want us to wait for 3 years, then only they can shut down the router and change do the modification. Okay, especially because that was a bank, and if they shut down that particular router which is in the hub site, okay, all their ATM machines, everything will go down. Okay, so they cannot do that. So what we can do here is we can change the MTU size on the operating system. That's what we did actually. Okay, we set the MTU value here in the operating system. If you are using a 2003 SP2 onwards, okay, we have come up with a registry value called as enable PMTU. Okay, that registry value can fix the issue. Okay, even the 2008 domain controllers can work well with that. Okay, but in 2008 R2, where we are using a SMB 2.1, you don't have to worry on the MTU size. Okay, in 2008 R2, the R2 domain controllers or R2 servers handle the packets MTU size by themselves. Okay, they work. It works very well with the SMB 2.1. Okay, and we have some of the tools we have. Okay, port query. Okay, how many of us have used the port query? Anybody use a port query? No. Okay, port query is one of the very good tool what we have. I'll just show you here. I go to the port query UI and I'll say I'll try to check the ports on the other DC. Okay, I can check the ports availability for particular service for domains and trust. Okay, port 88, port 135, 136, 137, all that will be queried if I select the domains and trust. Okay, or I can specify one custom port. If I say I want to query the port 445, okay, on this DC, I'll say query. Okay, can put in a notepad. The screen resolution is yeah, you can see here it is listening. Okay, so port query UI, port query actually when we release the port query, not everybody used it because it's a command line tool. Okay, but later Microsoft changed the port query to port query UI. Okay, where we have a user interface. Okay, you can make use of this port query UI and query the ports. Okay, it is really good, especially if you want to fight with your networking team. Okay, because they always say no. Okay, they open the port, they say we never block the port. Okay, so you can do a port query from your side and you can tell the networking team that okay, here is the result. I do this with the customers actually, and when we go and work with the customers, we will be working with the Active Directory team, and again there is a boundary with the Active Directory team and a networking team and a security team, all that. Okay. So we have a telnet tool. Okay, telnet also we can use to find out the port, if the port is working or not. Okay, but telnet only works for the TCP port. It will not work for the UDP. Okay, do the telnet connection on the port 445. Okay, if it goes like this, then it is listening. Okay, if a port 445 is not available, then it gives an error message saying that it could not connect. Okay, right now it is connected. So. And we have a netstat. Netstat is also a good tool to use. Netstat will show you that the domain controller is listening on which ports actually. Okay, if I go here, if I say netstat -a, you can see here this domain controller is listening on, currently it is listening on all these ports. If any communication comes to this domain controller, it can accept for the port 593, LDAP, 1025, all these things. Okay, sometimes we need to do this because when the networking guy says that, oh, okay, the router has port has been opened, okay, but we need to check on the server side as well because the server is listening on that port or not. Okay, so we can use a netstat as well, and we have a NS lookup. I hope NS lookup, everybody knows about NS lookup. NS lookup is a name server lookup. What we do with the NS lookup is
the last. So yeah.
Okay. With the NS lookup, we try to identify who is the service provider for me. Okay, if I go and check contoso.com, okay, it is telling me that I have two domain controllers, and the IP address of the two domain controllers is 2.1 and 1.1. Okay, so what happens is when a client is coming up, okay, there is something called as a DC locator process. In the DC locator process, client actually tries to find out with the DNS where it has to log in. Okay, it has a two types of queries. One is a direct DNS query. It does to find out where it can log in. If the DNS is failing, what it does is it does the NS lookup. Okay, it does the NS lookup and picks one of the IP address and tries to authenticate to that domain controller. Okay, the problem here is the NS lookup is good, but if this domain controller, what I have, this domain controller, if I do the demotion of this domain controller, the NS records of that particular domain controller will not be deleted automatically. Okay, we have to delete them, go and delete them manually. Okay, if you have a scavenging enabled, the scavenging makes sure that these records, NS records will be deleted automatically after 30 days or after 12 days or after 7 days. Okay, but the DC promo will not do that. We have to do that manually. Okay, so ping, everybody knows ping. Ping with a fully qualified domain name, ping with a short name, and a netmon. Netmon is a capturing tool. Okay, it's a trace capturing tool. We take a trace of this computer, what it is doing on the network. Okay, when you take a netmon trace, it's going to be a huge data. Okay, it's going to have thousands and thousands of frames you will have. Okay, we need to analyze one by one. We set a filter actually to analyze what traffic we want to see. Okay, analyzing the netmon trace is not just one day. You can learn the analyzing the netmon. You need to get experience with that. Okay, it's not just a netmon. You can learn the netmon tracing, analyzing the netmon trace. Sorry, you need to understand how the protocol works as well. You need to know how the TCP/IP works. You need to know how the DNS works. You need to know how the UDP works. You need to know there are so many protocols actually. You need to know everything. Okay, so when you know how the protocol works, you can directly go and find out in the netmon trace what is going on in the background. Okay. We also have a diagnostic tools for Active Directory, repadmin.exe. Many of the times I go to the customer place and the customer tells me that this domain controller is not replicating. What I do is I open the command prompt, I try to see the repadmin show REPL. I get a message saying that the command is not valid. Okay, why is because customers don't install the support tools. Okay, so it is very important for us to have the support tools on the domain controllers. Okay, you need to make a habit of putting a support tools on the domain controllers. Okay. So these are all the good tools what we have. Okay, and just to give you an example here. Okay, you can see here repadmin show REPL showing that it is able to replicate with the DC2, which partition and all that, successful, all that stuff. Okay, or If it is error message, it shows us the error message, all that. We have NL test. I told you about NL test. NL test can be used for the target principal name incorrect. NetDOM is for the domain controllers. We can use a DC DAC, okay, REPLMON, all these tools. AD best practices, okay, AD logical site mapped to the physical network site, okay, define subnet according to the site. Okay. This is really important because however you have a physical network, okay, you have to make sure that it reflects to the logical network in the Active Directory. Okay. If you don't do that, there are the cases we have seen a client is trying to authenticate to the DC which is in a different site, especially if that happens with the DFS. Okay, in the DFS, if a user is trying to access the Wellington user, instead of logging into the Wellington DC, if he logs into the Auckland DC and if he wants to access the share, he has to go all the way in the WAN link to access the file share. Okay, he'll make a whole network busy. Okay. So if you define the subnets according to the site here in the Active Directory, subnet sites and services. Okay, create a proper site and create a subnet and associate a subnet to the site. Okay, so if you do this, okay, when what we are doing here is we are creating. Okay, let me create another subnet and associate to the another site. Let's say new subnet 192.168.2.0 and assign it to Auckland. So what I'm doing here is I'm configuring this for my purpose, okay, and what my domain controller does is it has a service called as netlogon service. Okay, why we do this one is we want if a client from this particular subnet want to authenticate, okay, if a client from this particular subnet trying to authenticate, it should go to the DC which is in the Wellington. Okay, if a client from this subnet is trying to authenticate, it should go to the Auckland DC. Okay, so what happens when the client is coming up? Okay, it does a DC locator process. Okay, and how does the client knows that which site I need to log in? Does the client queries the Active Directory directly? No, it cannot query the Active Directory because it has to authenticate to the Active Directory before querying the Active Directory. So what happens here is whatever the records what we create here, okay, we have a service called as netlogon service. What that netlogon service does is the netlogon service puts these records into the DNS. Okay, so in the DNS, you can see here we have underscore MSDCS and here the site, which site, okay, all that. If a client is querying from the Auckland site, okay, the DNS identifies, okay, this client is coming from this subnet, okay, it has to get the Auckland domain controller. Okay, the DNS tells him that you need to log into the Auckland domain controller. Okay, so even if the client has moved from Wellington to Auckland, okay, or Auckland user has moved from here to there, when they try to log in, the DNS helps the computer to change the authenticating domain controller. Okay. Monitoring AD replication, you can use many tools to monitor the AD. You can use a MOM, you can use a SCOM, you can use any third party. You can also use passive monitoring. Okay, we have one of the tool called as ADRAP, Active Directory Risk Assessment Program. You can use the ADRAP to do the passive monitoring as well. You need to monitor the bridgehead servers more frequently. Okay, don't fix a DC which is which has got an issue, which has not replicated more than the tombstone lifetime. Okay, what is the tombstone lifetime? Is a time value. The tombstone lifetime of 2000 and 2003 servers is 60 days. Okay, the tombstone lifetime of the 2003 SP1 forest, okay, we increase the tombstone lifetime to 180 days. Okay, you can increase the tombstone lifetime, but never ever decrease the tombstone lifetime. Okay? If you decrease it, you will end up with a lot of lingering objects. Okay. And do not restore the system state longer than the tombstone lifetime. Okay, do not define bridget server connections manually. Okay. So that's about the Active Directory replication. Now let's take a look at the file replication service. Okay, whatever we have in the sysvol, okay, that sysvol information has to be replicated. Okay, so if I go here, if I go to the sysvol, so whatever I have here, okay, this needs to be replicated to all the domain controllers in that particular domain. Okay, so how does we do it? Okay, if you have a user object, the user object will be replicated by using the Active Directory replication, but these are the files and folders actually. Okay, how do we replicate these files and folders? We use one more service called as file replication service. Okay, we use a file replication service to replicate this information. And if you see the file replication service, FRS don't have anything itself to do the replication. Okay, FRS is very small engine actually. Okay, what FRS does is FRS always hooks to the Active Directory. It goes and requests the Active Directory to give the information. Okay, what FRS does is it uses the KCC connection objects which are already created by the Active Directory. Okay, by using Active Directory it does a replication. So if your AD replication is not happening, then you don't have to look at the FRS. FRS is already broken. Okay, so FRS is always depending on the AD replication. Okay, so the sysvol contains policies and scripts. Okay, those folders will be replicated only for the domain specific. It is not the forest wide. And sysvol uses the AD topology connection object for that. Okay, the best practices is low free disk space. Okay, but now I don't see the low disk space. Especially in Windows 2000, we had a lot of low disk space scenarios. Okay, so what happens is when a domain controller is coming up, there is a folder called as staging. Okay, what the FRS, how does the FRS replicate is, FRS when it want to replicate any information, like it want to replicate any of these things, what it does is it puts the data into a folder called as staging. Okay, so it puts the data into the staging, and the other DC comes to this staging, and it moves the data from here to that DC. Okay, for FRS to work properly, when the DC is coming up, okay, what the operating system does is it allocates 692 MB free space, hard disk free space to the FRS. Okay, what happens if you have a less than 1 GB of memory? If you have less than 1 GB of memory, you need a space for your paging file. Paging file is in a hard disk. Okay, so your paging file uses all the hard disk space, whatever you have in 1 GB, and you don't have space to create a staging folder. Okay, since the staging folder is not getting a space, free disk space, so the FRS service stops automatically. Okay, and poor connectivities. Yep, now we should not see the poor connectivities because we have a very good bandwidth everywhere. Okay, and excessive file updates. Okay, file in use or cannot be replaced. What happens is, I had one of the customer. What he did was, the application was he has one of the application. What he did was he put the application into the sysvol. He knows the sysvol gets replicated to every DC. Okay, and the user can access the DC sysvol and he can access the application. Okay, so what they did was they did a really big mistake. Okay, by doing that, okay, they put a lot of excessive replication. And what happens is when a user has opened that application, okay, there's an open handle with that application. Okay, when there is open handle, you cannot copy, you cannot delete, you cannot do anything. Even you cannot replicate that particular application files. Okay, so FRS goes on looping, and it cannot replicate the files and folders. Okay, since it cannot replicate these those files and folders, end up with the policies and the scripts. All those folders also don't replicate because everything goes into the queue. Okay, so don't stop the FRS service for extended time. Okay, don't configure the antivirus or defrag the sysvol. Don't configure the antivirus to scan your NTFRS, NTDS, and sysvol folders. Okay, don't store irrelevant files in sysvol. I have seen a customers who are putting a MP3 files in the sysvol. Okay. So do not manually copy the files in the sysvol between domain controllers. Okay, and don't change the file system permissions on the sysvol. The sysvol, the file permission, the share permission, whatever we have in the sysvol is completely automatic. Okay, so you should not be changing this share permissions. Okay, I have seen a lot of customers, they see that the sysvol was shared here, but the sysvol was not shared on the other computer, other domain controller. They go and share the sysvol manually. Okay, you should not be doing that manually. Okay, if a sysvol is not shared, you need to identify why the sysvol is not shared. You need to find the root cause of it. Okay. Again, the diagnostic tools, what we have with the FRS is sonar, ultrasound, NTFRS util, which is NTFRS util was available. As I told you, NTFRS is again depending upon the AD. We did not have any tool for the FRS, but in 2000 SP4 onwards, we got a tool called NTFRS util, and by using this util, we can do a lot of tasks. We can do that. Okay. FRS diag is one of the tool. Okay, this is really a very strong tool. FRS diag is going to collect the huge amount of logs. And DFS management and DFSR diag, these are the new tools for the DFS purpose. Especially these are not a DFS component, they are the DFSR component. Okay, if you are using a DFS, you don't see them, but if you use a DFSR, you will see them. Talking on the DNS, okay, so the DNS is, how do we configure the DNS? Okay, there are many ways to configure the DNS. What you need to do is there is no one standard way to configure the DNS. Okay, what I'm trying to say is, if you see here, I have a domain controller here in the parent domain. This is also a parent domain controller. Okay, they are on that particular site. Okay, and I have another child domain controller here. Okay, and they are in a different site. Okay, so for a redundancy purpose, what we need to do is we need to enable the forwarder. Okay, from here to here, here to here. Okay, we need to have a secondary zone on both sides. Okay, here we need to have c2.contoso.com as a secondary zone. Here we need to have a contoso.com as a secondary zone. Okay, this is the primary zone for itself. We need to have a secondary zone. Okay. Managing a secondary zone on every domain controller is administrative overhead. Okay, you got a new domain controller, go and create a primary zone, create a secondary zone. Okay, this is all. If you have a single for a single domain, it's very nice, very cool environment. But if you have different child domains, then you will end up with all these problems. Okay, so normally what I have seen is the customers actually they forward the request to the parent domain. Okay, and they have parent domain will forward it to the internet or ISP's DNS, but not everybody configures the parent also has to forward the request to the child domain. Okay, which is really important actually. Okay, we need to have a standard secondary zone. Okay, for all the domains and all the DCs, we need to have a forwarders. It needs to be in place for a redundancy purpose. And if you don't have that kind of thing, okay, if you have a child domain, okay, what Microsoft has done is in Windows 2003 onwards, we have something called as forest domain zones. Okay, if I mark this c2.contoso.com, this is a DNS zone as a forest level. Okay, this zone is available on every domain, every DC, every domain. Okay, but you need to be very careful when you do that. Okay, you might have to get your permission from your security team. Okay, what happens is if you have a secondary zone of the parent domain here, okay, so if somebody tries to delete those records from that contoso.com zone, they cannot do anything. Okay, the secondary zone keeps the read-only copy of the data. Okay, but if you change the zone to the forest level, it's a writable data. Okay, you may have to think twice before doing that. If I go here, you can see here I go to the contoso.com, I go to the properties, and here is I can change it to whatever I want. Okay, this is the Windows 2000 style. Okay, if I click here, and all the domain records will be moved to the domain partition. Okay, this is a 2003 style. Okay, and this is the 2003 domain level style. This is the 2003 forest level style of creating the forest level zone. Okay, if your domain environment is very secure, you can directly go ahead and create the make it. If you have a proper delegation is in place, okay, you can definitely go and make your DNS to the forest level. Yeah, in 2003 we added two more partitions, which is application partition, a domain DNS zone, and a forest DNS zone. Forwarders and a conditional forwarding. Okay, I have seen a lot of customers, they have just one gateway, and they say that okay, if a request is coming like this, do a conditional forwarding like this. Okay, if you have only one gateway, why do we need a conditional forwarding? Okay, if you have only one gateway, you just forward the request to that same gateway. Okay, why do you are stopping the request? Actually, it has to do the rule checking. Rule has to be checked here, right? So I have seen many customers who have got a one gateway and they try to create a conditional forwarding. Okay, and the stub zone. Stub zone is nothing but if you create a stub zone, you're going to have a record like a secondary zone. What we have, if you create a secondary zone, what will happen? Okay, I have one domain there, and I have a child domain here. I create a secondary zone of that domain here. It means that I have all the records available in that domain. Okay, especially what happens is if you are one forest and you buy another company which is in another forest, you just bought the company, you want to establish a trust, but you don't want to give access. You don't want to give all the access to those administrators in another company. Okay, you don't want them to see the servers or workstations what you have in your organization. What you can do is you can create a stub zone. When you create a stub zone, you just create only the SOA records and the NS records and the A records of the DNS server. Okay, you don't put a record of the client systems or anything. Okay, so this is the best practice is there's no single correct way of configuring a DNS. Okay, people create a secondary zone, forwarder, or make it as available to all the forest zones. Okay, and this is something important. DC point to itself, and the domain controller should be pointing to itself first. Okay, then it should be pointing to the nearest DC or a PDC. Okay, but actually sometimes we go to the customer's place and we change it to this style. Why all DCs are pointing to the single source? Okay, this we do it when we have a lot of issues with the customer environment. What we do is we take one of the DNS, we fix the DNS, and we start pointing all the DCs to that DNS. We fix all the DCs, then we say that your application is fine. Okay. So that's it. We talked on the AD, we talked on the FRS, we talked on the DNS. Got any questions? Yeah.
I just wonder, is there any way to point certain machines to a certain domain controller?
You should not be doing that. But what happens is in the DC locator process, okay, even though if there is a client which is in the Wellington site and you have given a preferred DNS in the Auckland site, right? The DC in the Auckland site. What happens is in the DC locator process, the client actually tries to check with the Auckland site DNS server where I have to log in. The Auckland DNS tells the client saying that you should log into your Wellington site DC because you are sitting in a Wellington. Okay, but since there is there might be a delay that the client is sending a packets to the Auckland. Okay, for that purpose, actually, we normally want to resolve the name in the Wellington itself. Yep.
Decommissioning a DC
Uh-huh.
and that's a bridgehead and wanting to get back to a sort of out of the box, if you like, replication rules.
Uh-huh.
come back or?
You don't have to do anything. You have automated bridgehead server. Go ahead and do the DC promo. The automated bridgehead server tells the other DCs that I'm going down. Okay, it tells the other DCs the moment it says the KCC connection objects will be removed from that domain controller with all the domain controllers. Okay, after 15 minutes the ISTG kicks in and ISTG identifies that there is no bridgehead server. Or if ISTG role is given to somebody else, ISTG role owner immediately assigns the bridgehead server to one of the other domain controller. Okay. Normally, by default, the first DC in a site will act as a bridgehead server with ISTG role. But due to maintenance, what we do is we shut down the DC. When the DC shuts down, automatically the other second DC, if it is available in that site, will elect as a bridgehead server. Thank you. Thanks, guys. Thank you, everybody.